My name's Adam. For those of you who were in the coding stream today, you probably have not met me, but so I'll reintroduce myself. My name's Adam. I'm one of the DoDs at QMIND this year. I'm wrapping up a 5th year here, just wrapping up an Apple degree. And this is my 3rd year at QMIND. I was a design member in my 3rd year, a PM in my 4th year, and then now obviously 5th year. I'm one of the DoDs. Super excited to be here and super excited to talk to you guys about starting a project, picking a model, just sort of the whole framework around the steps you should expect when working through a machine learning type project. For those of you who are in engineering, this presentation might seem very reminiscent of like Mod 1, Mod 3, except specifically applied to machine learning, because, well, surprise, surprise, those skills that you learn through like the whole APSC workload end up actually being some of the most applicable. You know, how to work through complex projects, how to break things down, how to think about stuff. So even if there are a couple of you rolling your eyes at the upon hearing Mod 1 and Mod 3, we're gonna get right into it. So machine learning projects. What are we going to talk about today? So we're going to talk about the structure of a typical ML project or data science project, whatever you want to call it, what is involved in implementing a model, and what to do when a project goes wrong or when a project goes really right. I think if there's time at the end, we can save some time for some Q&A. But other than that, I'll get right into it. So the ML process. The ML process seems kind of, I don't know, weird, kind of nebulous, but what you can actually do is you can break it up into the iterative design process, a very general iterative design process, much like any other project. These are sort of the general steps that you see. Some places define steps differently. This is sort of like the most general steps that I've seen. So you have to define your goal. I find that defining your goal should be the #1 step here. I know a lot of people who maybe think maybe getting the data might be the first step. Maybe I should swap these first two, but I really think having the goal defined and then using that goal to find your data is much more fruitful and can actually be a little more easy to work with. So you define your goal, get your data, and then there's the very long and arduous process of cleaning your data and enriching it. This cleaning and enriching data process, we'll get more into what that entails later, but it actually takes up, I would say, probably the most amount of time on average in any project. There's very few times you'll come across a project that has a data set that's extremely clean. You don't need to do anything to it. You can get straight to building models. Oftentimes you have 50, 60, 70% of your time just, cleaning data, making sure that it's usable. Then you'll find some insights, maybe visualize the data a little bit, look at it, see if there's anything you can use out of those insights to inform how your model works. And then at the very end, this very last step, deploying the machine learning model. That's the actual, that's what everybody wants to do. That's the fancy, like, implementing all these crazy algorithms type stuff. And it really actually ends up taking a very small portion of time in the whole project scheme of things. Deploying these machine learning models has been made very easy with a lot of the open source implementations and libraries out there. So a lot of people end up taking a lot of time with the first 5 steps. And obviously we want to iterate as many times as we possibly can. Iteration is a very good thing here. As with most projects, iteration can often lead to great improvement in your project. Looking at the marshmallow and spaghetti stick example that Ariana was talking about, the kindergartners were so good because they kept iterating. Anyways, we'll get more in depth into what each step in this process means. So defining the problem, this often means having like a 3 to 4 step or sentence problem definition. Like, can you a lot of this is just making sure everyone involved is clear on what is actually going on, what problem has been identified, what approach you're going to take to solve it, and how you're going to essentially assess whether or not you have succeeded or haven't succeeded. This step is extremely important to do well at the very beginning, because if you don't do it well, I guarantee you, as you go through into later parts of the project, you will have to end up filling in the gaps that you glossed over when you didn't do it the first time. So some key points to go through that might hint at you defining the problem properly is you have your 3 to 4 sentence problem definition. You have an extremely well-defined problem scope. What is your problem and what isn't your problem? What are you going to be doing? What is so far outlandish that you won't tackle in this project? You'll have a list of all the prerequisite background knowledge. I like to also call this just the motivation. Like, why are you even doing this? You could, if you don't do your background knowledge, you could spend all this time developing this crazy machine learning model and turn out that somebody made just like, I don't know, a program with one if statement that gets like 98% accuracy. So then it's just like you wasted 4 months. It'd be nice, along with this 3 to 4 sentence problem definition, is having your elevator pitch. If somebody came up to you and said, "What is your project?" you'd be able to tell them. Ideally, think like, I know a lot of people got asked this in their interview. Like, if your grandma came up to you and asked you what your project is about, would you be able to explain to them what it was? Make sure you identify all the stakeholders, everyone who's involved, and how they'd be affected, and then your requirements for success. So when you're iterating, you're going to have to iterate. You're going to have to stop iterating eventually, and that end of iteration will often come when you meet some form of success metric. So having that metric defined before you even start is super important. The one nice thing about QMIND is that your project managers have been working really hard over the whole summer to get this step pretty much under wraps. Hopefully, it'll just be a little bit of onboarding for you guys to make sure you're all up to speed on what this problem definition is. But you won't actually have to be doing much of it yourself. The next step, procuring or just getting the data. So you need to find a source of data that can solve the problem you just defined. There's lots of ways you can do this. If you watched my lecture earlier today, or workshop earlier today about data sourcing, we went over a couple of these. It can be something as easy as just copy pasting data. There's a public data set out there. You just, you download it and you use it. But other methods of maybe making your own data set, you have an API that you're leveraging, you're doing some web scraping, provided that's legal. Or if you want to get really fancy with it, I guess maybe ETL pipelines are a little bit, ETL stands for extract, transform, and load. And these are pipelines that you see in large businesses, essentially getting data from one point to another, either from their source to maybe your team, or from outside the company to inside the company. Those are just more, I guess, that's an industry term more than anything. And you'll also have to develop a method of storing your data. I don't know if you're doing something like the MNIST data set, that just means having a CSV on your laptop. If you have a large data set, you might even need to spin up a SQL database, or even start using some cloud storage as well. Just like the last step, your PMs have been thinking about this over the whole summer. They should have roughly an idea of what data they will have and how they're going to store it. There might need to be some finicky stuff, especially if you're on a client-facing project. Maybe they don't have their data yet, but most of this, or some of this, should be done already. The next step, cleaning and enriching the data. Like I said, this takes a while. It's a huge part of any machine learning project, and takes a great portion of time. Always takes more time than you expect it to. You need to format data properly. I think Mimi had a great feature engineering workshop about this, and there was also a working with data sets workshop that was great. Actually, I didn't see it. I'm just assuming it was great. But all about sort of the methods you could use to format your data properly, standardizing data types, making sure they're all floats or whatever you want, removing duplicates, nulls, and outliers, splitting data into your test, training, and validation sets to make sure that the model to fight overfitting and make sure that your model is very well, it performs well under generalizations, and just generally removing noise. You can also get into a little bit of feature engineering here, like combining or removing data sets, augmenting them with some random transformation. A great example of this that I see all over the place is of a great augmentation or transformation, I guess, is turning Cartesian coordinates into polar coordinates. It'd be annoying to draw this line to make a classifier, predict the difference or these two different classes between the green and blue classes with Cartesian coordinates. But with polar coordinates, it's much, much easier, and you can just have one line that separates all of it. This can eventually you can get into encodings, and even if you want to get really fancy with it, you can do some dimensionality reduction, which essentially means taking lots and lots of features and trying to find a way to combine them with some sort of linear algebra magic to make them be represented in a lower dimensional space. After you've cleaned your data, you can finally start looking at it and start analyzing it. This is often called exploratory data analysis, and it's all about making pretty plots, understanding the data qualitatively and quantitatively. These screenshots are from the workshop at the beginning of the day about the data science tools review. So right here we have some plots on the left, just random data sets using matplotlib. The matplotlib is extremely useful when you're trying to understand your data, and lots of the libraries out there that Python has have great tools for EDA work. You can find correlations between your data, between certain features and columns. You can do a full in-depth statistical investigation if that's your jazz. Maybe put all the stats courses you took to work for once. And then at the end, essentially, what you're looking for is a good understanding of what your data looks like and a good idea of how you could use it to make an appropriate model. Lastly, we get to the step of developing your machine learning model. Like I said, this is the stuff that everyone likes doing. This is the implementing the neural nets and I don't know, like running the 40-hour training sessions on your laptops. So what you're looking for here is you're taking a bunch of potential models. Ethan was talking about an overview of all the machine learning algorithms out there to build models. You can use those to you can use that to sort of jump off and understand which models could potentially be useful for you, train them, test them, observe their performance, and see here we have our predefined success metrics. So if you didn't define what was successful early on in your project, you're now going to have to go all the way back to step one and say, okay, well, what the hell does success even mean? Did we get success? Did we not? It's just annoying to go backtrack, so make sure you do it in the beginning. But you're essentially observing your performance, fine-tuning these hyperparameters, which is essentially meaning like just twisting knobs until you get, I don't know, let's say from 97 to 98% accuracy. And then if you're very successful, you'll be deploying your model. Just a little note, like I said before, the steps probably actually only going to be like 10% of your project. Like it's not. It takes a few lines only to implement a model. It'll be mostly the cleaning and enriching that takes up the biggest portion of your time. And then lastly, iterate. This, I'm sure people have seen a diagram something like this before. Essentially what I want to get across is that at any point in time during the phases of your project, you can go backwards. You can recognize, hey, maybe we didn't understand this properly. Hey, maybe this wasn't fully what we were going for. Let's take a step back. Let's define the task a little bit better. Let's collect some more data. Maybe our model just has a ceiling. It will never get as good as we want. Maybe we need to, redefine what success is. Stuff like that. Iterate. It's great. Some extra notes. I guess I've probably covered most of these already, but the tasks, I guess no, this one I haven't, but the tasks don't necessarily need to be in this order. I would recommend that they follow roughly this structure, but for example, if you could do some some exploratory data analysis before you get to the data cleaning process. You could switch those. This isn't some be-all and end-all framework that you need to follow. I think it's just a good guideline and a good way to mentally track what you're doing. Always be watchful of bias. There's some great examples, well, really they're unfortunate examples of bias negatively impacting the performance of machine learning models, whether it be, I don't know, I think the go-to example is facial recognition models that are better at recognizing white male and Asian male faces, because that's mainly who works on like demographically, that's who works on these models. It's kind of insane that, like, you know, there were giant $1 million projects that had these levels of bias ingrained in them. So always be watching out for it. It can really impact your model, and it can negatively impact whatever you're using these models in. Iteration doesn't always mean improvement, and that's okay. I think that's a great kind of mindset to be in. If you go back and things don't work, things don't improve when you iterate, that's fine. That means you just either go back, or at least at the very least, you now have learned something new about what not to do. So it's always great, even if you're not improving. Like I said, pre-processing always takes longer than expected. There are going to be times where you're going to be sick of pandas, you're going to be sick of NumPy. Just power through it, get that stuff through, and you'll have some really cool models in no time. And lastly, the PMs, like I said, have been working on steps 1 and 2, but they aren't finished, especially with some of the client-facing projects, some of the client-facing, or I guess some of the contracts and stuff, you know, maybe they haven't been fully sorted out yet, so nobody's been able to look at the data. You might have to help the PMs out a little bit, but so yeah, just be wary of that. Yeah, that's about it for the model portion. Or sorry, the framework of a machine learning project. Now I'm going to look a little bit into picking a model. You know, like how do you decide which model to actually use and go forward with, or I guess deploy. There are a few common success metrics. You could use just different forms of accuracy. There's 1,000,000,001 different accuracy metrics you can look into. All depends on, you know, whether you're doing classification or regression, or is it a binary classification, or are there multi-class. There's lots of stuff you can look into. Some of the most common ones I've seen: precision, recall, and F1. Those are great when you have some data sets that are heavily skewed to one side or another. Root mean squared error. You have this thing called a confusion matrix, which is just this picture right here with that highlights true positives, true negatives, false positive, false negatives. All those accuracy metrics are, you know, great things to decide whether or not your project is a success. But there's some other things that you might want to look into specifically, and these really depend more so on your project, whether these are something you should consider or not. But I don't know, I think it's worth noting. Your training time might be something you need to consider. Maybe your model is being retrained every week and once a week, and it takes 24 hours to train. Do you have the bandwidth to train a model for 24 hours every 7 days? Maybe that's not in the cards for you, and that means you're going to have to focus on a model that can train, or that trains in less time. The inference time, you know, some models take a millisecond to get you from input to output, or to get you from input to prediction. Some models take half a second, and, you know, like a millisecond versus half a second might not seem like a lot, but if you're running a real-time system or something with a lot of requests coming in, that inference time can actually, you know, be pretty impactful in the success of your model. The computation required, it's pretty heavily linked, or pretty closely linked to inference time. I think I just wanted to talk about computation specifically because of how prevalent, like, cloud computing is in, I guess, industry now. If you have a very computationally heavy model, or just project in general, it's going to run you more, because a lot of these cloud computing services run on how much computation you did. So you can run your costs up there. And then obviously you have your classic business metrics. So how many people did this problem actually solve? Or how many how many people were affected by this problem, and how many of them will experience, like a solved state of the problem, or how many problems just in general did you solve? How much time did you save? How much money did you save your business? Those things are all great common success metrics to look into when you're defining your problem. And the last thing I want to talk about today is just changing your project scope. So what happens if, something goes wrong, or ideally what happens if something goes extremely right and you find yourself finished by like December? So when things go wrong, especially since this is a club at the end of the day, project timelines can get messed up. Schoolwork can pick up, people can drop off the face of the earth for 3 weeks or just quit entirely. Nobody's being paid here, so I guess as annoying as a move as it would be to go AWOL, it is a possibility you have to think about. And if you're working with a client, they can oftentimes be demanding and pushy since you guys are just students and not full-blown, full-time employees. So what can you do? You can talk about if somebody's missing, or if you guys aren't able to do work for a solid month because you're all busy. Talk about a reduction of scope. Talk about what that would mean as a team. Just make sure you're communicating effectively. Specifically with the client side of things, stand up to scope creep. Stand up to making sure that the project scope you set out in your contract is the same scope that you deliver on. A lot of the times, some of the people you work with might not even realize that they're scope creep. They might just be going off on their own and thinking, oh, this would be great to do, this would be great to do, and just pushing it all on you without realizing that they're pushing the scope larger and larger and larger. But at the end of the day, make sure you're communicating effectively and reach out to your DODs and project managers and just anyone at QMIND. There are lots of resources here for you. We also have a list of, a ton of resources outside of QMIND that you might need for support or just anything. I think Wendy has a great list of those, so definitely reach out to her if you need it. But, we're here to support you. We're here to make sure you have a great time. What to do when things go right. Hopefully this happens to everyone. But let's say your team is running ahead of schedule. Maybe look to Sean and turn your project into a product. Maybe you're an innovation team and what you have by December is this really, really good model, but it's just in a Jupyter notebook right now and it's just kind of sitting there. Reach out to somebody, see if you can productionalize this thing. You can get like a web app going that shows off how cool your project is. That would be great on a resume to say, not only did I make this machine learning model, but you can go check it out at this website here. I think that'd be pretty cool. Maybe raise your requirements for success. Maybe things went so well because you set accuracy. Your requirement for success is like an accuracy of 85%, and your first model hit like 90. Then just raise the bar. See if you can outdo yourself. You have time. Why not? You could also look for, this is for client-facing projects. You could move forward with your client on integration stuff. This is a little bit tricky, and I wouldn't recommend unless you actually have like experience in the field. But talk about like a future state of your project. What would it take to get your project from where it is now to something that's integrated into all of their systems? That would require, you understanding the system and really starts to get deep into the consulting side of QMIND consulting. Like I said, it'd be great to really do that, but just caution. Make sure you know what you're doing. Last thing, you could create a package out of your project or make a library or whatever you want. That's what happened with one of our projects, I think 2 years ago. It was called Happy Transformer. They set out to make a package or a library, whatever you want to call it, that made working with BERT, making like essentially transformer models, a lot easier to work with. I think last I checked, they had like 20,000 downloads. So I don't know, it was like a really cool project and got some really cool exposure. I think the PM for that project ended up founding a company. I'm sure he's doing great things right now. And last thing you could do is just write a killer paper for QCI. Like make sure your paper that you're submitting to QCI is just absolutely knockout. I don't know, some great things you could do if your project's going right. But that's pretty much everything I have for today for you guys. I'd love to hear any questions. I think, how much time do we have? We have like 10 minutes before Yes, Venify AI. Eric Fillion, he was the project manager, and that was his company, doing cool stuff. But yeah, if you guys have any questions for me or for any of the directors, I don't know, it doesn't have to be about the presentation. Feel free to fire them off. Yeah, thanks for coming, guys. Really appreciate it. Oh, Jordan Capello. They said they're sending a. Oh, never mind. Ethan already answered it. Cool. Yeah, no problem. Thanks, Rami. I appreciate that. This is great. I love this. This is just an ego pump for me now. All right. Well, I don't know. Maybe I'll head out. I feel weird just having 95 people watching me, but it was great. I don't know. Great presenting for all of you guys, and please reach out. I'd love to meet as many people as possible. Reach out on Slack or LinkedIn or whatever. Bye.